Hi, today I'm going to show you Novi's data engine, a powerful tool to build analytics-ready data sets in minutes. The way the data engine works is that you can upload sources, that's things like well headers, production, directional surveys, and subsurface sources, merge together different sources of the same type to form a collection, and then join across those different collections to form a data set. So let's get into it. I'm going to go ahead and pull up this well header source that I've uploaded. We're working with a Wood Mackenzie header file from the Midland Basin. And the way that it works is that there's a variety of different known output fields that our data and model building pipelines know what to do with. That can be things like cultural information, regions, states, dates, lengths, locations, completions information, etc. And I'll show you this little lateral length column here to start. You map in a column from your input data, so this is from my Midland header source, so it's called lateral length feet in that source, and the units are in feet. If it were meters, I could select meters. Same thing for the other, if it's proppant, you can do pounds, tons, etc., kilograms. And data engine will surface to us if we have any issues with invalid data. So let's say I uploaded a string instead of a decimal field, and anything that's empty. So I click this little preview button and it'll let me know, okay, yeah, for these wells I have empty for lateral length. So if that's a surprise, I can go back and remedy the issue. All of this stuff is important stuff that we've kind of learned over the years, is required to get to an accurate data set sustainably. Production and directional surveys uploads are very similar. Subsurface is a little bit different. I'll pull up this map of porosity thickness for the Wolfcamp A as one example. So we've loaded in this grid. It corresponds to the Wolfcamp A formation. The rock property represents porosity thickness. We specify the CRS, and then it'll give us a little preview down here. So it's important to make sure that all of this stuff is consistent, it's showing up in the right location, that it's the right grid in order to get that analytics ready data set. So that looks good. I'm going to go ahead and cancel out. So next up, I'll pop up to the well headers here under the collections. And what this allows you to do is to merge across different well header sources. So I'm actually just going to create one here and show you how that works. So we'll call this merge demo April, hit the OK button. And the way that it works is that you can specify different well sources here that you want to merge together. So let's say I want to grab one from this Midland header file. Let me go ahead and save that one. Then let's say I've uploaded my own operated headers. So let's bring that one in. And then let's also add in, let's say I've just traded for some data. So I'll bring those in. The operated is actually going to be my highest confidence, so I'm going to rank that one top. Second highest is going to be those traded headers, and the third is going to be my third-party data source there. One other thing that I want to add in, I'm going to bring in a directional survey collection because for certain items, I'm going to be able to calculate those off of the surveys. Lateral length, for instance, I could get perf to perf from an operated completions file. Maybe I have my own estimates, but you can also derive that from the directional surveys based on inclination stability or a certain cutoff, right? So if I look down here in the table, I have all those different output fields, and it's grabbing it from whichever, it's grabbing it if it's present in that source. So we'll see some pieces of information may be present in all three. Other ones, let's say stage count or total clusters, those may only be present in proprietary data sources. Some things I may only be able to get from surveys. So let's say tortuosity measurements or toe angles. That's stuff that our software is calculating automatically. So pretty powerful little tool here to help you get to those analytics ready data sets quickly and blend together these different data sets that you have the largest number of data and highest quality data that you can actually believe in. Let me pull up the Subsurface Collections here. This allows you to kind of, okay, I've uploaded these 12 different rock properties. I have these different formations that are represented, and this is just allowing me to check to make sure that, okay, yes, I actually have a grid that represents the net permeability thickness for the Wolfcamp B or whatever it is. And then if I want to take a look, I can kind of browse over and see who uploaded that, what actual metadata is associated with that grid, and take a look if that's a surprise. We do also have a couple other pieces here that are kind of required to get to that accurate data set. We have the alias lists. So let me pull this open. We have a pretty clean list of formations here, but you may have some instances where you have a spelling error, you have underscores versus spaces, lots of different reasons you may need to alias something. And this allows you to kind of map those unaliased formations down to an alias to clean that up for the model building purposes. I also want to show you our spacing configuration here. So it's important for analytics within oil and gas. You have to know what the spacing of your wells is, and we actually will calculate over 50 different spacing features based on the directional surveys, surface holes, and bottom hole locations that you upload here on the sources. But you do need some different parameters to make those calculations. So for instance, how far out should our software be looking to find a neighbor? What we've learned is that the answer to that question may be different in the Permian versus in the Eagle Ford versus in the Bakken, for instance, depending on your permeability, geomechanics, etc. And so we actually allow you to do a variety of different customizations there to make sure that these spacing calculations match your own understandings. Another example down here that you can customize is the frequency of those spacing calculations. So we allow you to make those on a weekly, monthly, or quarterly basis. And stay tuned for a future video where we'll be exploring some of those powerful time series spacing outputs. Okay, next I'll kind of wrap this up at the dataset level. So I'll go ahead and create a dataset and show you the full workflow right here. Demo April. For this demo, for this data set build, the way that it works is that you're joining together across these different data types. So that's, it's very important to be able to join your production data to your header data, to join use your spacing parameters to calculate correct spacing and then join that in. You have to do spatial joins for your subsurface, so don't need to go into GIS and do things by hand. We will actually handle all of those spatial joins from the well locations just with our software. And you can configure a couple items down here at the configuration. One of those, like I just mentioned, is that sampling that you do with the subsurface. So, okay, yeah, let's sample at the bottom hole, and I want to be extrapolating at most 10 miles away from the edge of my grids. Maybe that's 5 miles, maybe that's 3 miles. It's kind of up to you. And then specify what production date you're using down there for the spacing field. So next I'm going to go to this review button, and this lets me know, okay, I had 2,600 wells with header information. Of those, I had 1,300 that actually had production data. So this can give you a good idea of, okay, yes, this is going to be kind of the starting point for my analytics ready data set. Everything is going to be published in the cloud, but this is just kind of your preview of what it might look like when you go to start filtering to build your model. Okay, so that all looks good. Final step here is I'm going to hit that build button, and it's going to start running and let me know when that data set is built, and kind of send me an email, and it'll go up into the cloud where it can be reviewed and used for analytics, whether that's for Novi's modeling or your own internal purposes. So thanks for listening. It's a pretty powerful tool. I've kind of haven't had a chance to walk you through everything, but if you want to learn more about it, just reach out below. Thanks for your time today.